Okay, well, it's, was it Wednesday, January 8th, 2020? I did just record something yesterday, though I haven't posted it yet on Iterations of Zero. But, I wanted to sort of just get a quick thing off my chest. It's something that's been bouncing around in my head for a long time. And I've actually thought of sending an email or a comment to Sean Carroll's blog about it because it's not that he made me think of it first, but sort of made me think of it more in his recent book. I've been thinking a lot about, I would say, for those who know me, know probably that I've always loved physics. And I've been thinking a lot about quantum mechanics and so forth in recent time. I recently read Sean Carroll's new book, Something Deeply Hidden. I've read his previous books, but I've also been influenced by Max Tegmark's books, particularly Our Mathematical Universe, because his next book, Life 3.0, is a totally separate subject matter. But I've also, of course, read David Deutsch, his books, The Fabric of Reality, and The Beginning of Infinity. I need to set my cell phone to silent, I think. Anyway, so obviously all these people are not only sort of more convinced of the so-called many worlds interpretation of quantum mechanics, the Everettian picture. And so obviously I've been influenced by that. But of course, like everybody else, when I first heard about and learned about quantum mechanics at all, it was always the classic Copenhagen interpretation, the shut up and calculate, don't ask questions about what it means even for the wave function to collapse. It works, we get results. That's what matters. Of course, as many great scientists have thought, not that I am one, but I mean that their thoughts are legitimate, just having a tool that works isn't enough if you're actually trying to explore the nature of reality, which ultimately was what science is about, knowing science, You want to try to probe it more deeply, more fundamentally, try to tease out the logic and the mechanics to the best of your ability and our collective ability, which is very great indeed, so that you can actually get a complete picture of the whole thing. That being said, getting down to the Everettian wave function and its comparisons. Okay, where was I? Basically, I first of all, I know that it's a historical accident, that it's called the many worlds interpretation, but I don't even like to think of it as the many worlds interpretation, because it implies you're adding something after the fact, that it produces these things as if there were one world to start with and then you suddenly made a lot of them. I think it's better, in fact, just to call it the unitary wave function interpretation of quantum mechanics. The wave function is all that there is. It never collapses. There's no, because there's never any explanation for how it would collapse. What on earth would be the process of a wave function that is spread out, suddenly collapsing somewhere? But it does imply that in places where the wave function describes a superposition, that superpositions, both of them really have an existence. And if they decohere, and, there can be quote-unquote two possible outcomes, everything consequent to that decoherence is also split. And the logic of that is fairly straightforward. It's sort of like having a choose-your-own-adventure book, in a way. All the outcomes of the choose-your-own-adventure book, if you open the door, go to page 56. If you turn around and go back down the hall, go to page 75. All the outcomes are written. They exist. You only ever do one at a time when you're following that path, because you're following that path. Now, this all seems very straightforward to me, and I don't understand why it's complicated to people. The thing that's people get hung up on the idea, but wait, if there's all these other worlds, why don't I experience them? No, I don't know, in a choose your own adventure book, why don't you experience both decisions you made at the same time? Why aren't you reading 2 pages at once? Because you're not. It's not the way the logic works. It's not the way the program works. If you're playing a video game and you can turn right or turn left at some point, you don't feel like you're going both right and left at any given time, because you're not. But both outcomes are there in the game. They exist in the Hilbert space of the game, if you'll pardon my expression. Anyway, so the idea of the wave function separating and everything, or rather parts of the wave function separating and then no longer ever interacting with each other subsequently, doesn't seem very odd to me at all. It's sort of like if you had ripples on a pond caused by falling raindrops, but it's only drizzling and there's only a few drops, and imagine there's no friction in the pond dissipating the waves would pass each other by and briefly have a local additive effect, but then they would separate out and never encounter each other again, but both would be just as real. That's not a very good analogy. I'm sure I could come up with something better. Anyway, this notion made me think about Fourier analysis. Now, I'm not an expert by about a million miles in Fourier analysis, but the idea is basically that any complex wave pattern, I think it's usually used in sound, but it doesn't have to be, can be broken down into a combination of simple waves and wavelets, i.e., some combination of sinusoidal waveforms, either ongoing or brief, superimposed upon each other additively, producing the large-scale waveform like my voice. Now, I know that you can produce almost any wave function mathematically, mathematically by doing this, and that in principle, all waves can be broken down in this way. And it just leads me to wonder whether there is some overlap in these ideas, i.e. is the global wave function, the wave function of the universe, of which there is only one, if ever it is right. But it is one really big, very complicated wave function. And it can be looked at small scales, and you can ignore the other stuff while you're looking at something small. And that may be the equivalent of Fourier analysis. And indeed, the very phenomenon of many worlds, so to speak, of the fact that we only experience one of the two wave outcomes when they're mutually inconsistent with when they lead to different future iterations in their local branch of the wave function, they are like wavelets, or one particular sinusoidal wave pattern next to another, maybe out of phase, or whatever sinusoidal wave pattern, that don't have to have any interaction with each other. They don't notice each other. A sine wave doesn't notice another sine wave that happens to be going on at the same time. It doesn't change it. It changes the overall picture. To the listener, whoever's listening to the universe's wave function may notice a difference. But the individual sine wave in a Fourier analysis doesn't get affected by all the other wavelets and sine waves of the various different frequencies, amplitudes, and so forth. It just keeps doing what it does. That's a much simpler wave than the wave function, because we have to remember, the wave function isn't a wave in water, it isn't a wave in electromagnetic radiation, it isn't a wave in the gravitational field, it's a wave of some other, it's a wave in complex space, in Hilbert space, which is a potentially infinite dimensional space, if that's correct. Mathematically speaking, it is, but, it's an infinite dimensional space in which we describe the wave function. In any case, whatever the wave function is, it's not confined to 3 dimensions of space and 1 dimension of time, and not even probably legitimately described by 10 dimensions of space and 1 dimension of time or whatever. It seems to be something more complicated than that. Again, it's in complex space with your square roots of -1 and all that other stuff. So we shouldn't be surprised if the way our wave experienced by us, who our nature has shaped us to be able to perceive and conceptualize 3 dimensions of space and to a loose degree 1 dimension of time, shouldn't be obvious. But it's also not that mysterious if you just think about the math. You use your imagination. I mean, we have computer games and movies and all these other things that posit so many contrafactuals. That's one of the reasons I liked the old computer games, because they actually, because they had to be simplistic, games like Tempest and stuff like that, they didn't even try to simulate a real-world environment. It was just pure game. It's like chess doesn't happen in the real world. Chess happens in the chess world. Tempest happens in the Tempest world. The laws of physics there are not what we experience. So in a way, it's almost a bad thing. It's almost too bad that games get too good at simulating the real world as we experience it. I like the games that simulate things that have nothing to do with the real world, or only very indirectly, because obviously we have to interact with them. That helps your imagination. But you can imagine multiple dimensions. You can imagine waves separating into two sub-waves going along and no longer interacting with each other. It's not that hard to do. And that they exist, they're not only close to each other, they're literally in the same place, but because they're different waves, they don't affect each other. The one sine wave goes along as it goes, the other sine wave continues to go along as it goes, and only from the outside perspective can you see them both, or hear them both, or whatever. That seems to me to be a way to get around the problem that people have with the many worlds interpretation. I lean toward the many worlds interpretation precisely because it's the most parsimonious. It just basically says, look, we got the wave function. The wave function works. Everything we've ever done with the wave function works. Why are we making up other stuff? Why are we using sleight of hand to throw in a wave function collapse and then trying to give explanations for that? There's no collapse. It's just the wave spreading out and having separate aspects, all of which are then subsequently carrying on as before, but each one on its own, in the sense that it doesn't any longer get changed by the other portion of the wave from which it came. I'm sure I'll talk more about this later, but I had to sort of just get this out while I was thinking about it and had enough caffeine in my system to do it. Thank you.